Hello, everyone. Welcome to today's episode of the Daily AI Brief. Today, we're diving into some of the most intriguing recent advancements and discussions in AI technology. From Google's TurboQuant compression algorithm to innovations in nuclear energy, we've got a power-packed lineup for you. Our focus is on technical breakthroughs, practical implications, and the ethical considerations that come with integrating these technologies into our daily workflows. Stay tuned as we unpack these developments and explore their impacts on the world of software engineering and beyond. Google's latest innovation, TurboQuant, represents a significant advancement in optimizing large language models, LLMs. With an impressive reduction of key-value cache memory by a factor of 6, coupled with up to an 8-fold improvement in processing speed, TurboQuant is setting a new benchmark in LLM efficiency, all while maintaining zero accuracy loss. TurboQuant employs dynamic compression strategies specifically targeting key-value KV caches within LLMs. This approach utilizes advanced algorithms to optimize both memory usage and computational speed. At its core, TurboQuant integrates a context-aware approach to cache management, which allows it to dynamically adjust its compression techniques based on the specific workload demands it encounters. This adaptability mimics the efficiency witnessed in contemporary algorithms like DynSplit, KV, and ZAC, reflecting a trend towards more flexible cache handling. Performance metrics offer a compelling case for TurboQuant, a 6x reduction in the size of KV caches and speedups of up to 8x during model inference, all while maintaining 99% of the baseline accuracy. These advancements translate into considerable operational cost savings for businesses employing LLMs, surpassing the capabilities of competitors like ZAC, which achieves only a 68% reduction in KV cache size. Despite these promising developments, some questions remain about TurboQuant's broad applicability. Specifics of its implementation across different LLM architectures are still emerging. There might be potential compatibility challenges, especially when integrating TurboQuant with existing systems. Additionally, the algorithm's reliance on dynamic adjustments raises concerns about performance predictability under varying workload scenarios. Real-world validation will be crucial to confirming these gains and ensuring that the theoretical advancements translate to practical efficiencies. For those interested in exploring TurboQuant further, Google's research blog provides detailed technical documentation. Practical steps include testing the algorithm in current LLM deployments to benchmark performance improvements and comparing its efficacy against existing KV compression techniques. In summary, TurboQuant embodies a potential turning point for AI efficiency, offering lower operational costs and improved performance without compromising accuracy. If proven in diverse real-world settings, it could redefine how enterprises deploy and utilize AI technology. NVIDIA recently launched PivotRL, a transformative AI framework designed to revolutionize language model fine-tuning. Through a pioneering combination of supervised fine-tuning, SFT, and end-to-end reinforcement learning, E2ERL, PivotRL achieves significant accuracy improvements with reduced computational strain. The framework enhances in-domain task performance by 4.17% and out-of-domain tasks by a remarkable 10.04%, all while requiring only 1/4 of the rollout turns typical in traditional methods. The key to PivotRL's efficiency lies in its blend of baseline efficiency and adaptive learning. Supervised fine-tuning provides a strong initial setup by handling specific task trajectories efficiently. It sets the stage for E2ERL, which precisely tunes out-of-domain anomalies through interactive learning, ensuring a balanced and efficient training process. This synthesis allows enterprises to quickly prototype and deploy models using NVIDIA's Nemotron 3 Super 120B A12B architecture, renowned for supporting large-scale deployments. Technically, the framework achieves E2ERL equivalent performance with a drastic reduction of 75% in rollout turns, highlighting its computational advantages. Practically, this means organizations can fine-tune their models significantly faster without incurring the heavy computational costs often associated with comprehensive on-policy rollouts. While this is an impressive feat, there are trade-offs to consider. For instance, while reducing rollout turns, there could be increased demand on other resources, such as memory, which may impact overall efficiency. Moreover, the robustness of PivotRL across various domains is still under evaluation. Questions about its adaptability and performance under dynamic and evolving conditions are yet to be entirely addressed. Implementing PivotRL involves accessing detailed methodologies and metrics available in its research paper on rxiv.org. For those interested in utilizing this technology, NVIDIA provides starter code through its developer resources, facilitating initial trials and integration into existing projects. Enterprises already deploying PivotRL have reportedly experienced notable improvements, as observed in several case studies. In conclusion, PivotRL represents a significant leap forward in AI model training efficiency. By cutting down resource demands while enhancing performance, it democratizes access to advanced AI capabilities, supporting broader industry adoption and innovation. Its potential to reshape AI model training and deployment is considerable, promising more cost-effective and resource-efficient AI solutions for the future. Krane's significant advancement in AI technology comes to the construction industry, with its platform receiving $9 million in seed funding, a testament to its potential impact on the historically tech-averse sector. This platform is crafted to address key inefficiencies in construction supply chains by utilizing AI to manage materials, eliminate project delays, and minimize waste. At its core, Krane's platform leverages sophisticated AI algorithms that enable real-time tracking and comprehensive material management. The application is equipped with end-to-end connectivity, ensuring seamless communication among stakeholders across the supply chain. One of the notable technical components is its predictive analytics capability, which forecasts material demands and timelines, allowing construction projects to anticipate and mitigate potential bottlenecks before they occur. The integration of a cloud-based interface ensures that documents and essential data are accessible instantly, promoting a smoother decision-making process through robust data visualization tools. Moreover, it integrates easily with existing construction management systems to guarantee wide usability without the need for overhauls. The reception to Krane's innovation, marked by this substantial $9 million funding round, reflects a burgeoning confidence in AI-driven solutions within the construction sphere. It's a significant leap when compared to other players like Build-A, which raised $1.9 million in 2021, demonstrating a competitive yet promising environment for tech investment. Despite such promising advancements, there are trade-offs and uncertainties surrounding Krane's offering. Details on the full range of platform features and the forecasted timeline for its deployment are not yet fleshed out. Additionally, the industry poses challenges due to its slow adoption rate of new technologies, which may affect how readily Krane's platform is embraced. Traditional practices often impede rapid technological integration, presenting a cultural barrier that Krane must navigate effectively. For those interested in how this transformative tool will unfold, keeping abreast of Krane's updates through their official channels and social media is crucial. Engaging with case studies or demonstration versions, once they become available, can provide real-world insights into the platform's functionality and benefits. In summary, Krane's platform isn't just another tech innovation. It represents the potential evolution of construction supply chains. By driving efficiencies through AI, Krane could significantly reduce costs and expedite project timelines, suggesting a forward-looking shift in construction technology that might well define future industry standards. Oracle's recent announcement at Java 1 aligns with a growing need to integrate AI into mainstream development platforms like Java, enhancing its capabilities for AI-driven projects. This initiative is pivotal considering the increasing demand for AI solutions across various industries. A cornerstone of this development is the introduction of the Vector API in Java 24. The Vector API is specifically designed to facilitate AI workloads by allowing computations to be expressed as vector operations. This can dramatically increase the performance of AI algorithms, particularly in machine learning tasks like data preprocessing and neural network training. Developers can expect performance improvements up to 10 times over non-vectorized code for certain operations. Such enhancements position Java as a viable choice for AI development, comparable to languages traditionally favored in AI such as Python and R. Oracle has unveiled 22 new AI-powered applications under the Fusion Agentic brand. These are multifaceted, covering enterprise areas such as human resources, supply chain management, payroll, and customer experience. These applications are designed to enable businesses to capitalize on real-time data processing steps, thus optimizing decision-making processes. By leveraging AI, these applications can identify patterns and insights that manual processes might overlook, offering enterprises a competitive edge through automation and smarter operations. However, the integration of these AI capabilities into existing Java applications raises several uncertainties. While Oracle aims to maintain compatibility, the transition may present challenges, particularly for legacy systems that might not easily accommodate the new features. Moreover, the real return on investment, ROI, from deploying these AI applications remains speculative until more businesses report on their operational impacts. To practically engage with these advancements, developers are encouraged to explore the AI features embedded in Java 24. Testing the Vector API's capabilities with varied AI workloads can help gauge performance enhancements. Additionally, participating in Oracle's future Java 1 events can provide valuable insights and hands-on experience through demos and sessions dedicated to AI integration. Oracle's strategic shift to embed AI into Java represents not only a technical enhancement, but a vision for the future where human expertise is amplified by intelligent technologies. This evolution promises to reshape the software landscape, driving both increased adoption among developers and improved efficiencies across business applications. Microsoft and NVIDIA have initiated a pivotal collaboration that leverages artificial intelligence, AI, to overhaul nuclear energy project delivery. The focus is on drastically improving efficiency in the construction and operational phases of nuclear plants, utilizing AI's capacity to manage complex data and simulations. At the core of this partnership is the deployment of AI algorithms designed to detect documentation inconsistencies often encountered in extensive nuclear projects. These AI tools streamline workflows by automating the identification and resolution of errors, leading to more cohesive project management practices. One of the standout applications of AI in this initiative is the creation and implementation of digital twins. These are detailed virtual replicas of nuclear plants, allowing engineers to test modifications and operational strategies in a risk-free digital environment before actual implementation. By facilitating pre-adjustment testing and simulations, digital twins have the potential to significantly reduce costs associated with trial and error and improve the reliability of processes and equipment. Quantifying these benefits, ALO Atomics, under similar conditions, achieved an impressive 92% reduction in the time required for nuclear permitting using generative AI. This reduction translates into an estimated $80 million in annual savings, highlighting the financial viability of integrating AI into nuclear projects. Additionally, NVIDIA is backing these endeavors with substantial investments in AI infrastructure, aiming to develop what could be the world's most powerful data center by early 2026. This infrastructure is crucial for supporting extensive AI computations required for advanced simulations and data analytics in nuclear projects. However, this innovative approach is not without challenges. While the objectives and benefits are clear, specific methodologies for AI integration in nuclear energy projects have not been disclosed, raising questions about deployment strategies and the scalability of these technologies. Regulatory compliance poses another significant hurdle, as nuclear energy involves strict safety protocols and regulatory scrutiny. Furthermore, the effectiveness of these AI solutions in real-world scenarios, along with public acceptance of AI in critical industries like nuclear energy, remains uncertain. This uncertainty extends to the workforce, raising questions about how AI might impact traditional roles in nuclear sectors. For stakeholders and industry participants interested in exploring this domain, it is worthwhile to investigate the potential applications of digital twin technology in nuclear construction and to test AI tools designed for identifying documentation errors. Monitoring the ongoing results from this partnership, especially in terms of real-world impacts and efficiency improvements, can provide valuable insights into AI's transformative role. Ultimately, the partnership between Microsoft and NVIDIA holds the promise of revolutionizing nuclear energy, potentially setting new industry standards through improved efficiency and cost effectiveness, facilitated by advanced AI solutions. If successful, it could not only redefine nuclear project management, but also influence global energy policies and encourage further investments in AI-driven energy technologies. LlamaParse, traditionally known for its robust table parsing capabilities in PDF files, is now setting sights on improving parsing functionality for Word.docs documents. This move aims to resolve long-standing difficulties in extracting complex table data from Word documents, a critical function for enterprises that rely heavily on accurate data retrieval for strategic decision-making. LlamaParse functions as an API dedicated to parsing and representing documents for enhanced context augmentation, integrating seamlessly with the Llama Index framework. It produces outputs in a structured Markdown format specifically designed to handle documents with intricate tabular data. This capability is essential for supporting retrieval augmented generation (RAG) workflows, which enable sophisticated question answering systems over both tabular and unstructured data. A significant challenge that LlamaParse addresses is the extraction of accurate, complex multi-row and multi-column tables that are often embedded in Word documents. These tables can include nested data and merged cells, posing difficulties for conventional parsing tools. By focusing on this area, LlamaParse seeks to enhance overall user experience and operational efficiency within enterprise settings. Despite its promises, LlamaParse's documentation currently lacks explicit details regarding the extension of these capabilities to Word documents. The official documentation predominantly outlines support for PDF files, leaving users with uncertainty about the advertised Word document capabilities. This lack of clear communication highlights the need for users to verify updated documentation and potentially seek community feedback or case studies where the new functionalities might have been employed. In terms of technical performance, key metrics such as parsing speed, latency, and accuracy remain unspecified. This absence of concrete benchmarks makes it challenging to assess the immediate impact or efficiency of the enhancements, especially in comparison to existing PDF-focused solutions. Users interested in integrating this technology into their workflows should experiment with LlamaParse's current PDF functionalities while remaining vigilant for updates that confirm Word document support. For practical application, enterprises should weigh the potential benefits of LlamaParse's promised Word document parsing against the current gaps in verification. With increasing reliance on automated document processing systems, the need for reliable and versatile parsing tools is crucial. Assuming successful integration, these improvements could significantly streamline data extraction processes from Word documents, potentially leading to more effective data analysis and improved business insights. However, it's vital to proceed cautiously given the current lack of official confirmation for these new features. Users are advised to stay informed by regularly checking for updates in the LlamaParse documentation and exploring discussions within technical communities. While the potential for improved workflow automation and efficiency is enticing, the speculative nature of these enhancements requires careful consideration before full-scale adoption. Recent findings by Zhao et al. Challenge the authenticity of chain of thought, CoT, reasoning in AI, indicating that many reasoning steps are decorative rather than indicative of true cognitive processing. This revelation is significant, particularly for AI systems employed in critical decision-making roles, where transparency and reliability are paramount. The study's core contribution is the introduction of the True Thinking Score, TTS, which quantitatively measures the true contribution of reasoning steps in AI models. TTS sheds light on the fact that only a limited subset of reasoning steps have a significant impact on a model's predictions. Despite the elaborate reasoning chains that AI can articulate, these often lack genuine execution, creating a disconnect between apparent reasoning and internal processes. CoT reasoning, praised for handling complex tasks, now faces scrutiny due to its superficial outputs. This has profound implications for AI's trustworthiness, especially in fields like healthcare, finance, and autonomous systems, where decision-making integrity is vital. As AI models increasingly undertake complex tasks, these superficial reasoning outputs can lead to misguided trust and potential errors if not properly understood and validated. Researchers and developers are encouraged to incorporate TTS into their evaluation frameworks. By doing so, they can better assess the efficacy of reasoning steps and ensure systems genuinely support decision-making processes. Additionally, frameworks such as Concept Walk can be explored to trace internal activations, offering deeper insight into model operations. For practitioners, replicating these findings involves delving into Zhao et al.'s publication and supplementary materials, enabling the adaptation of their methodologies in diverse contexts. This scrutiny of co-T reasoning, facilitated through TTS, is crucial for bolstering the credibility of AI decision-making. However, skepticism remains regarding its reliability across different models and scenarios. While TTS provides a robust framework for evaluating reasoning steps, questions linger about the general reliability and application of co-T reasoning across various models and tasks. Developers and researchers must explore these uncertainties, iterating on findings to refine methodologies and enhance reasoning authenticity. Ultimately, this ongoing analysis is essential for fostering trust in AI systems and ensuring they meet the high standards required for critical applications. Proteina-Complexa is transforming the landscape of protein binder design through its innovative application of artificial intelligence. This model leverages advanced computational biology techniques to radically streamline the creation of therapeutic protein binders, which are critical for drug discovery and tackling a variety of diseases. At the core of Proteina-Complexa is a latent generative search framework that effectively encodes amino acid sequences alongside their all-atom structures. This is achieved using a sophisticated flow-based generative model, trained extensively on large protein structure datasets. Such an approach allows the model to not only predict, but also generate de novo protein binders with impressive accuracy, thus surpassing many existing methodologies in the field. The performance metrics of Proteina-Complexa are compelling. It achieves a hit rate of 63.5% against PDGFR with picomolar affinity, highlighting its high efficiency. Additionally, it can produce nanomolar binders for muscle-wasting receptors without the need for conventional affinity maturation. The model also demonstrates hit rates of 40 to 50% for kinase mini-protein and peptide binders. These figures are significant as they indicate the model's potential to accelerate drug discovery processes, cutting down timelines and associated costs traditionally involved in experimental approaches. Proteina-Complexa's development was a collaborative effort involving NVIDIA and Evozine, utilizing NVIDIA's BioNeMo platform, which is instrumental for protein generation and design. BioNeMo's capabilities facilitate not only the training of such complex models, but also their deployment in practical settings, offering researchers a cutting-edge platform for therapeutic development. However, like any pioneering technology, Proteina-Complexa presents certain trade-offs and limitations. The long-term stability of protein binders generated by the model in real-world clinical scenarios remains a topic of ongoing research. There are also concerns regarding the model's scalability when applied to a broader array of targets and the potential for off-target effects or immunogenic responses, which could affect its applicability in diverse therapeutic contexts. For those interested in exploring the practical applications of Proteina-Complexa, NVIDIA provides comprehensive resources through its BioNeMo platform, including detailed guides and demonstrations. Engaging with these resources can provide valuable insights for researchers and developers looking to integrate this technology into specific drug discovery projects. In conclusion, Proteina-Complexa represents a significant leap forward in protein design, promising to reshape the future of drug development by making it more efficient and cost-effective. Nevertheless, although current results are promising, ongoing validation in real-world applications will be crucial to fully realizing the model's potential. JetBrains has introduced Central, a groundbreaking platform designed to optimize the management of AI coding agents, thereby enhancing productivity and streamlining development workflows. This launch reflects JetBrains' strategy to integrate AI capabilities more seamlessly into software development, significantly benefiting developers using their integrated development environments, IDEs. The unveiling of JetBrains Central is aligned with the company's recent releases of AI agents, Junie and Claude. Notably, Junie has showcased impressive capabilities, successfully solving 53.6% of tasks on the Yebench verified benchmark, a testimony to its efficacy in handling routine coding tasks. This benchmark acts as a critical measure of AI performance in software engineering environments, highlighting areas where AI can best supplement human developers. Meanwhile, Claude, introduced in September 2025 and built on Anthropic's robust Agent SDK, further enhances the coding assistance provided within JetBrains' ecosystem. This integration is designed to offer sophisticated AI support without necessitating additional plugins, thereby simplifying the user experience and reducing the overhead costs associated with AI adoption. JetBrains Central is more than just an AI agent platform. It includes advanced analytics and the JetBrains console, tools that grant teams deeper insights into AI performance and usage statistics. These features enable organizations to monitor AI agent performance comprehensively, allowing for adjustments that can improve efficiency and quality over time. By providing centralized management capabilities, Central aims to tackle one of the primary challenges faced by enterprises today: managing multiple AI tools effectively without fragmenting workflow control. This centralized approach can lead to significant reductions in development time and improvements in code quality, fostering an environment where AI and human activities are optimally balanced. Despite these advancements, questions regarding the real-world efficacy of agents like Claude persist. The potential for AI tools to transform traditional software practices is substantial, but developers are cautious about adopting new workflows that rely heavily on AI. Concerns include maintaining oversight, ensuring quality control, and understanding the full impact of these tools in varied coding environments. There are also ongoing debates about how AI might alter developer roles and responsibilities, emphasizing the need for a balanced adoption strategy. For professionals interested in exploring these new tools, JetBrains Central offers a free tier for local AI models, allowing developers to experiment without committing to additional costs. Users can test the Junie agent to see its capabilities in action and explore its integration in their current setups. Meanwhile, the Vector API can be reviewed as part of a broader strategic implementation to maximize the benefits derived from these AI solutions. In summary, JetBrains Central represents a pivotal development in the realm of AI-powered coding, facilitating a more integrated, efficient framework for managing AI tools. As AI continues to shape the future landscape of software development, platforms like Central will play a crucial role in bridging human ingenuity and artificial intelligence, ultimately fostering more efficient and innovative development processes. TinyLoRA introduces a transformative approach to fine-tuning large language models, LLMs, by utilizing an astonishingly compact set of only 13 trainable parameters. This method allows the Qwen 2.5 model, which contains 8 billion parameters, to achieve a remarkable accuracy of 91.8% on the GSM-8K benchmark. This high level of performance with minimal parameter alteration signifies a radical departure from traditional fine-tuning methods that typically require updates involving anywhere from 100 to 1,000 times more parameters. The core of TinyLoRA's methodology lies in the use of low-rank adapters, which scale down as small as one parameter, combined with the principles of reinforcement learning. This integration facilitates efficient enhancement of reasoning capabilities embedded within pre-trained models. Unlike conventional supervised fine-tuning that necessitates extensive parameter modifications, TinyLoRA stands out by keeping the majority of model weights frozen, thus preserving computational resources and speeding up the personalization of models. Amazingly, the total size of changes required to achieve the desired performance stands at merely 26 bytes, which illustrates the method's potential for scalability and application in low-resource environments. This efficiency can be crucial in scenarios where storage and processing capabilities are limited, thus making advanced AI model deployment more accessible. Nevertheless, despite its promising aspects, several considerations remain. The long-term stability and the ability of models fine-tuned with such a minimal parameter set to generalize across different domains need further evaluation. Moreover, while reinforcement learning provides efficiency, it may not be universally applicable across diverse application scenarios. Questions also persist regarding the scalability of this approach to even larger models. For those interested in exploring TinyLoRA further, it's recommended to delve into the paper Learning to Reason in 13 Parameters available on Arxiv. This can provide deeper insight into the methodology and its practical implementation. Additionally, experimenting with TinyLoRA on small-scale LLMs can offer hands-on understanding of its capabilities and limitations. Ultimately, TinyLoRA represents a significant leap in model fine-tuning strategies, promising to democratize AI model deployment by significantly lowering the resource footprint. While it shows potential for a broad impact, particularly in resource-constrained settings, the challenge of scalability and generalizability remains an area for future exploration and research. That concludes today's in-depth exploration of AI's rapidly evolving landscape. We've navigated through technical advancements, practical applications, and the ethical considerations that accompany AI integration. As these developments unfold, they not only enhance technological capabilities, but also prompt us to refine our approaches to oversight and trust in AI systems. Join us next time as we continue to unravel the intricacies of AI innovation. Thank you for tuning in to the Daily AI Brief.